All right, Algebra 2, Chapter 4, Section 7, Inverse Matrices and Systems. All right, we got a lot of stuff we're going to learn in this lesson. We're going to learn to solve systems of equations using the inverses we talked about earlier. And we're going to learn how to do a coefficient matrix, a variable matrix, and a constant matrix. Okay, pretty easy stuff once we get rolling. So, objective 1, solving systems of equations. Okay, the first thing we have to do is we have to represent the systems of equations with a matrix equation. So here's our system. I have x plus 2y equals 5 and 3x plus 5y equals 14. So my matrix equation is going to look like this. It's going to be the coefficients of my x values, 1 and 3, the coefficients of my y values, 2 and 5, and then the order I have them paired up, x, y, and then the solutions are the constants, 5, 14. So the coefficient matrix is 1, 2, 3, 5. The variable matrix is x, y, and the constant matrix is 5, 14. So if you notice something on this, what you notice is this looks like an AX equals B matrix. So we can solve for matrix X if we find the inverse of A. Remember, X equals the inverse of A times B. Okay, so we understand the coefficients, the variable, and the constant matrices. All right, so here's the first example. Write the system as a matrix equation. All right, so let's look at the first one. So I have negative b plus 2c equals 4, a plus b minus c equals 0, 2a plus 3c equals 11. Okay, so the very first one, what's my a coefficient? 0. The second one, what's my b coefficient? Negative 1. What's my c coefficient? 2. What's my constant, or the solution? 4. Second equation, what's my a coefficient? 1. What's my b coefficient? 1. What's my c coefficient? Negative 1. And what's my constant? 0. Last one. What's my a coefficient? 2. What's my b coefficient? 0, because there's no b. What's my c coefficient? 3. What's my constant? 11. And since it was set up a, b, c, we write the variables a, b, c. So my coefficient matrix is right here, my variable matrix right here, and my constant matrix. Okay, understand when you set up your equations, make sure you line up your variables, okay? Next slide. So how do we solve these equations? So we're given 2x plus 3y equals 11, and x plus 2y equals 6. Okay, we've learned a few ways to solve these equations by substitution, elimination, and all that good stuff. All right, so let's set up our matrices. Okay, so what's my first coefficient? 2. What's my y coefficient? 3. Okay, we're going to leave that blank for now. And what's my constant coefficient? It's the solution, 11. Okay, let's go to the next one. What's my x coefficient? Well, it's 1. What's my y coefficient? It's 2. What's my constant? 6. And since it's in order x, y, my variable coefficient is x, y. Does this look like A unknown equals B? So if that's the case, all I have to do is go x equals the inverse of matrix A, okay, times matrix B. So let's look at matrix A. What's the determinant of matrix A? Okay, if you remember, it's going to be 2 times 2 minus 3 times 1. So that's 4 minus 3, so that's 1. All right, so what is the inverse of A? It's going to be 1 over the determinant, which is 1. Okay, it's going to be D negative B negative CA. So let's just plug in the values. So our inverse of A is 1 over 1. The D value is 2. My B value, negative B, is negative 3. Negative C is negative 1. And my A value is 2. So my determinant is, or sorry, not the determinant, my inverse is 2, negative 3, negative 1, 2. So we said X equals the inverse of A times matrix B. So I'm going to have XY equals my A matrix. My A inverse is 2, negative 3, negative 1, 2. My B matrix is 11 and 6. So can I multiply those together? Yes, I'm going to have a 2 by 2 times a 2 by 1. So I'm going to have a 2 by 1 matrix. So let's go ahead and do it. So I have XY equals, first row times first column, 2 times 11 is 22, plus negative 3 times 6 is negative 18. So 22 plus negative 18 is 4. Negative 1 times 11 is negative 11, plus 2 times 6 is 12, so it'd be 1. So my matrix XY is equal to 4, 1. So X equals 4 and Y equals 1. And we can go back and plug that in if we'd like, okay? So X equals 4 and Y equals 1. And we can go back and plug that into the original equation. Okay, next example, real world example. A bead store has on sale certain beads. The price for each size of bead is given. Relate 2 large beads plus 3 small beads is cost $3.25. 3 large beads and 4 small beads equal $4.75. So we're going to make a matrix equation. So first thing we're going to say 2 large plus 3 small equals $3.25. 3 large plus 4 small equals $4.75. Okay? So what's the coefficient? So let's go ahead and write our equations out. What's the coefficient of the first one? 2, 3. So I have L and S are my 2 variables. So coefficient of L is 3. The coefficient of S is 4. And my solution is 3.25 and 4.75. So I have a matrix equation. So I have AX equals B. So I know X is going to be the inverse of A times matrix B. So we got to find the inverse of A. So step 1, find the determinant of matrix A. That's going to be 2 times 4, which is 8, minus 3 times 3, which is 9. So the determinant's going to be negative 1. All right. The inverse of A is 1 over the determinant, which is negative 1. Okay, and if you remember, it's going to be D value, which is 4. Okay. Negative B, which is negative 3. Negative C, which is negative 3. And our A value, which is 2. So we just got to flip the signs because that's what it means with a negative 1 on the outside. So the inverse equation, the inverse of A is negative 4, 3, 3, negative 2. So matrix X, which we can replace with LS for the large beads and the small beads, is going to be equal to the product of negative 4, 3, 3, negative 2 times 3.25 and 4.75. So here we go. So LS is going to equal a 2 by 1 matrix. So negative 4 times 325 is going to be negative 13. 3 times 475, all right, is going to be 1425. So that's going to simmer down or reduce to 125. Okay. Does everybody see how I got that? First row times first column. Okay, now go. There's no more columns, so go. Second row times first column. So 3 times 325 is 975 plus negative 2 times 475 would be negative 9.50. So 9.75 plus plus negative 9.50 would be 0.25. So we have a solution, L and S. So we know our large beads cost $1.25 and our small beads cost 25 cents. Okay? Last part we wanted to cover. When coefficient matrices of a system have an inverse, the system has a unique solution, meaning one solution. Similarly, when coefficient matrix does not have an inverse, the system does not have a unique solution. In that case, the system either has no solution or infinitely many solutions. All right. So write the coefficient matrix for the system. Use it to determine whether the system has a unique solution or not. So here's the first example. Okay. X plus y equals 3. X minus y equals 7. All right, so let's write the coefficient. What's the coefficient of the first x? 1. Coefficient of the first y? 1. Coefficient of the second x? 1. Coefficient of the second y? Negative 1. Okay. My variables, they're both in order, so it's just going to be x, y. And my constant's going to be 3, 7. So first step, we just got to find if there is a unique solution. So 1 times the determinant of matrix A is 1 times negative 1 minus 1 times 1. So that's going to be negative 1 minus 1. So the determinant of A is negative 2. So yes, there is a unique solution. It didn't ask us to solve it, did it? So it's a unique solution. All right, next one. I'm given the equation x plus 2y equals 5. 2x plus 4y equals 8. So let's look at it. So the coefficient matrix, the first x, the coefficient's 1. The first y, the coefficient is 2. All right. The variables are both in order, so we can just make that x, y. The coefficient matrix is 5, 8. Okay, so let's go on. Second equation, the x coefficient is 2, the y coefficient is 4. So step 1, find the determinant of matrix A. That's going to be 1 times 4 minus 2 times 2. So that's going to be 4 minus 4, which is 0. Since the determinant is equal to 0, there is no unique solution. Okay? So now we've looked at it. We've been able to use the inverse matrix properties to find and solve systems of equations. We also learned if the determinant is 0, there's no unique solution. If the determinant is not 0, there exists a unique solution. Okay?